Okay, so next we create our first object, object Zool. We use the stand right sprite, but we need to remember to set the depth to -1. Now what depth means is it controls the order in which sprites are drawn. So the lower the number, the higher that object being drawn will look. So in this case, if you say -1, I look at that as being 1. Depth is kind of inverse logic, where if you say a depth of 10, that's 10 feet underground. If you set a depth of -1, that means it's 1 meter above the ground. And so that's always going to be drawn last. You want Zool to be always drawn last. So you got to set the depth to -1. So we're creating our new object, our first Zool object. And again, use the names in the book, please. Don't use your own names, because this game is hard enough trying to remember which name goes where. So I would just suggest using the ones in the book. I'm going to make that a requirement, actually. So it's not a suggestion, it's a requirement. Otherwise, it's too hard to debug. And we go and get our Zool sprite. And we want to set that depth to -1. That's super important. Okay, and there's our first Zool object. So all the Zools will have a depth of -1, and then object Zool will be their parent. So that's also very important. So let's do that now. -1. So it says walk for land, jump for air. Here, we want to set the parent to object Zool. And I want to put object Zool first here in the window. This would be jump right. They're kind of assuming right. -1, and set the parent to object Zool. Climb for wall, slip for ice. Okay, so the important thing is make sure it's a child of object Zool, and also set the depth to -1. Now that we have the object, we want to hang him in midair. Don't put him on the ground, because we want him to fall into place. He'll go through all the different states correctly if you do that. So I put him, where did I put him? I put him maybe right here in the air. And what will happen is he'll realize he's in the air, and then he'll fall, go into the falling state, and then when he hits the ground, he'll go in the standing state. If we play the game right now, nothing's going to happen. It's just going to sit there. There he is, hanging in there. Okay? So now we have to give it some sort of behavior. We want Zool to just be able to walk. That's our goal maybe for today. Maybe a little bit more. Because now let's create some simple walking functionality. We'll begin by setting up the parent object, which can contain any functionality that's common to all Zool states. All the child objects inherit the events and actions of this object. One of the key functions we'll make parent option perform for all states is it will draw the appropriate sprite for Zool's current state. So the drawing is all in the parent. The parent object will also be the first Zool object that gets created on each level. So that we use the create event to set default values for variables as well. So it's really important in the create event that we put these things in Zool parent objects create event. First thing we have to do is get Zool facing in a certain direction. So let's do that now. Object Zool, we add the create event. Which variable are we creating? We go to the control tab, grab the variable, and we say variable is facing. And the value is actually that constant we made, face underscore left. Okay. So when any of the Zool objects get created, the first thing it's going to do is create this facing variable, and it's going to set it to face left. You'll be able to get to this facing variable in any of the Zool object states. Now, first thing we do is we change the instance, is we change it to object Zool land and set the perform events equals yes. This last option makes sure that the destroy event of each object Zool and the create event of every object we're changing into are both called as part of this action, in that order. We only mentioned the create event in the past. We don't use destroy events very often. Okay. The next thing it has to do in the create event is to change object. That's this one on the main one menu. And we're changing it into object Zool land. And we're setting perform events to yes. That's super important to set that to yes. Okay, so we want to do an outside room event. In this case, we want to wrap the screen. So when we go off the right side of the room, we want to come in on the left side of the room. A lot of people have problems with this part here, and Zool keeps falling through the floor, so I want to make sure everybody's got this right. So you add the outside room event. Say add event, other, outside room. Once Zool goes outside the room, we want to wrap the screen. And we're just going to do horizontal wrapping. We're not going to do vertical wrapping. So that's, you've seen games that wrap before. You go over the right side of the screen. If you ever played Asteroids, that's the way it works. So we're going to do that here. Now we have to add a draw event. And then we have to draw the different states. Remember, it's the responsibility of the parent object Zool to draw all the other states. We have to first test to see which way we're facing. And then we have a little bit of work to do. This all happens in the draw event. Now in GameMaker, you can't draw anything outside of the draw event. All the drawing has to be in the draw event. You can't draw it, just call it anywhere, the drawing commands. So we're going to add a draw event here. And it's the responsibility of this object to draw all the other Zool states. So the first question we have to ask is which way it's facing. So we ask that question. So our variable is called facing. Well, we want to check to see if it's equal to face right. So if object Zool is facing to the right, then we have to figure out which state object Zool is in. So we put a startup block, and then we have to ask more questions. We check to see if it's in the standing state. If so, we change it to sprite Zool stand right. Okay. So again, we test. Our variable is, well, what is our variable? If we look at the create event, here in the create event, before we change to another object, the order is important. So right there, we're going to just have this called, we'll just call it state. And the variable we want to change is state. Don't say relative. So now we have our state variable. Now in our draw event we can test it. So that's here. Again, the variable is called state, and we're testing for the standing state. So if it's equal to z state stand, we want to change our sprite. Yeah, so this is a mistake in the book. Yeah, they have the wrong icon. The draw sprite icon is actually this one. Okay. So in the book it has the wrong one. So here we're going to say this is the standing state.
Yeah,
so
and it's also stand right. So.
Yeah. And we say relative. Now the subimage of -1 means when you change the sprite, don't reset the image index so that you're allowing the animation to go even though perhaps you're changing the sprite to itself. It doesn't reset the subimage. And then we just do a set of these. If we're in the standing state, we change the sprite to stand right, walk right. And it looks like that's all they want for this one. So let's do that. Finish this off. So I'm just going to copy these two. Place them here. So if we're in the walking state, then we change it to sprite walk right. Keeping it relative. And then it's important to put an end of block. Now they have you ask to see if facing is face left. But we already know it's face left because if it's not right, it's left. So I'm not going to do what the book says and put one of these out there because that's redundant. We already know the answer. So we're just going to say else. So I'm just copying this down. And if it's z state stand, but we're looking to the left, we just have to change the sprite to the left sprite instead of the right. Right. And then closing. I'm going to save that. We've got the drawing part sorted out in the parent object. Now we want to do the land state, and look at all that. Yeah, so there's a lot to do there. I'll just plow through it, I guess. So we go to Object Tool Land, we do a set variable action, and we set the variable state to z state stand. Let's do that. The event is the create event, and we set the variable state equal to z state stand. Next we put gravity, and we're going to set the direction downward, but the gravity set to 0. Probably we're shutting off gravity. We'll keep it the same direction, but the direction is still 270, which is down. But we want to set the gravity to 0. We're using friction. We use friction in the tank game, if you did the tank game. So we're using it here too. So we want Zool to be able to slide right and left a bit. So we're going to set the friction to 1. And that's here. That's kind of a new one. Next we set the vertical speed to 0. So here's vertical speed. That'll stop him from moving up and down. Then we add a keyboard left event, and we set the horizontal action that sets the horizontal speed relative to a value of negative 2.5. Okay, this applies a force on Zool towards the left when the left key is held. The size of this movement is 1 greater than the friction force, so it will gradually build up speed by 1.5 pixels per step. We set the horizontal speed then, so negative 2.5 relative. So now we set the variable state to walk, since he's trying to walk to the left. So here, set the variable state to z state walk. Be careful as you put these in, because you're not picking from a list, you're actually just typing. So if you put in the wrong name, you're going to crash once you get to that point. So we include a set variable action and sets the variable facing to face left. So we're just telling the game that that Zool is facing to the left now. Now I'm going to copy. I said negative 2.5. We have friction of 1, so if you're not holding down the left key, it's going to slow down by a factor of 1, I guess. I want to do the same thing for the right key press or keyboard. Here we change the horizontal speed to 2.5 relative, and change this to right instead of left. Okay. Next we add a step begin step event, include the set variable action that sets the variable state to z state stand. You might think that putting this in begin step event would mean that Zool always ends up being drawn in the standing state, but we will explain why that's not the case in the next section. So I guess we just do it for now and take their word for it. So this is the begin step event. So we add that event, step. Usually we just do a step event, but here we're doing a step begin step event. And it says change state equal to z state stand. Now we add a collision event with object solid. So that will include everything. Because remember, everything derives from object solid except for Zool, it would seem. So we add that collision event. We choose object solid. So what should happen when we hit something solid? We set the variable of x to x previous. In the case where Zool is going so fast that he ends up inside a wall or through the floor, they want to back him up 1 frame, so just before the collision happens. What we say here is we set x equal to x previous. So whatever location Zool was at, we're going to put him back to that previous location. And we'll do the same thing with y. So y equals y previous. And then we do move to contact, which is kind of new for us. So there's no maximum, and it's against all objects. And what it will do is it will slowly move Zool closer and closer to what it collided with until it collides completely. So there is move to contact. It's on the Move menu. Direction will be just direction. Whatever direction it was going, we're going to go in the same direction. And we're going to say all objects. So that's kind of a new one, but allows us to move in increments that are different than the grid size. Finally, we set the speed action to 0. This now provides us with the same kind of collision event as used in Fishpod game. Object Zool land. Objects should look like this. So we're setting the horizontal speed to 0. And again, I'm saving it here. Well, let's just try it. Oh no, he's there. Hey, look, I'm moving. Woo. I'm in midair though. Oh. So that's pretty cool. And he speeds up too, which is kind of neat. Okay, so that's all for today. I think we got things working.